Alright, so today we're going to be graphing some more sine and cosine graphs, but adding in phase and vertical shifts. So take a second, jot down what these are. If you need to pause the video, pause it. But a phase shift is a shift that moves your graph right or left. Vertical sounds like vertical, means up or down. Pretty basic. Here's our fully formulated versions of the equations that we'll use for graphing. So once again, pause, take a second to jot it down. I'll just briefly go through all of these. So here is sine, here is cosine. One thing to make your life a lot easier is I factor out a value from both the x and the number being added or subtracted to the x. And that allows us to quickly find b, and it also gives us your phase shift right off the bat instead of having to do some calculations for it. So amplitude, absolute value of a, period, 2 pi over b. Now here, the phase shift, this is the opposite sign of the phase shift. So if this is x minus 3, then your phase shift is positive 3. If this was x plus 2, then your phase shift would be it would be minus 2. It's because it's the opposite sign. Then your vertical shift is k. And you'll see k, sometimes they'll be in the back of the equation. It doesn't actually matter if it's in the front or the back. It's just a difference in notation, but they mean the same thing. So when we're graphing, basically all we're doing now is we're going to do the exact same stuff we did in the previous lesson, except once we have the base graph, which is what we'll call the previous graphing we were doing, then you'll shift it over to the right or left, and then you'll move it up or down. And so it's actually pretty simple. It's just an extra step or two that we're adding in here. So let's look at this guy. So here, what we're going to want to do, see how this is not factored out at all. We want to factor that 2 out first of inside the parentheses. So we're going to have a 2 sine, and then we want to take a 2 out because we want the x by itself. It's pretty easy to know what to factor. So we're taking a 2 out of there. How you would do that is you would actually just multiply this by half, because we want to be able to, if we were to multiply it back in, we want it to cancel. So we're going to take pi over 2, multiply it by a half, and that comes out to be pi over 4. So that's how you would factor with a fraction there. So here's our new equation. So that's our amplitude. So amplitude will equal 2. That is b. So the period of the graph would equal 2 pi over 2, which is just pi. And that is our phase shift. So our phase shift is going to equal the opposite sign of that, so it's going to be negative pi over 4. Vertical shift is 0. The vertical shift would technically be the thing that's being added or subtracted in front or behind. So that's why there's nothing there, so our phase shift is 0. So let's mark all this stuff on our graph. So we have an amplitude of 2, so that's 1, -1, -2. Now our phase shift is our period is pi. Now we're going to want to leave a little extra space, because with the phase shift we might have to move up a point or two in either direction. So here we know the period is pi, so then that's a half, that's a fourth, so 1/4, 2/4, that would be 3/4 pi, or 3 pi over 4. So now we have our graph all labeled, and let's graph. So it's a sine graph, so it's going to start here. Intercept, maximum, intercept, minimum, intercept. So let's draw this in as a dotted line, because it's going to get moved when we apply our shifts. So here's what it looks like to start. That's our base graph. So our phase shift means we're going back pi over 4. So what that's telling me is I'm going to have to move every point by negative pi over 4 or by pi over 4 to the left. So this point will now move here and goes right there. This point goes back 1 to here. This point goes back 1 to there. That goes back 1 to here. and then that guy goes back a point to here. So our final graph is actually going to be through those points. And you can see, if you compare the green to the purple dashed graph, all I did is just basically shifted the graph, or just moved the whole thing to the left by 1 point, or by 0.4, or sorry, by pi over 4. So that's what we're doing with phase shifts and vertical shifts. And in this case, we plotted our base graph. So we plotted essentially these two values first. So they go first. This one we would plot second, and then if there's a phase shift, it goes third. That's the steps for graphing. Okay, so here we do have all different types. We have a vertical shift, we have amplitude change, and everything else. So let's rewrite it. 2 plus 3 cosine, we have to factor out the 3, which means we have x plus pi over 3. So we're just multiplying that value by 1/3, because that's a reciprocal of 3. So then, let's see, amplitude will equal 3. Period will be 2 pi over 3, because that's 3 right there. Phase shift is negative pi over 3. Vertical shift is 2. Alright, so let's start graphing here. So period's 2 pi over 3. This is a negative phase shift, which means I'm going to be adding some, the graph's going to go in that direction. So leave myself some space. Let's move that a little bit here. So that's 2 pi over 3. That's 2 pi over 6. Pi over 6. That's not the best looking number ever. 3 pi over 6. 1, 2, 3, 4. Yep. Alright, then we have an amplitude of 3. 1, 2, 3. Negative 1, negative 2, negative 3. Okay, so our first graph, amplitude is 3. Period 2 pi over 3, it's cosine, so it starts up top, goes down, comes back up. Once again, I would draw this guy dashed or slightly, because with 3 graphs on one line, it can get kind of confusing. So that's our first graph. So now we want to make the phase shift. So pi over 3, well, these are all 6's. So let's put that in terms, same denominator, so that would be negative 2 pi over 6. All I did is multiply the top and bottom by 2. So this is telling me each point goes back 2. So let's see, there's 1, so that'd be negative pi over 6. That'd be negative 2 pi over 6. So this point, we're looking at this graph, goes back 1, 2, goes here. This point, 1, 2. That point, 1, 2. That point, 1, 2. That point goes 1, 2. And let's draw that line again. And take a second to check. It should still look the same, like the same shape. If it looks way off, then we probably did something wrong. In that case, I know it's not drawn prettiest, but it still works. So then, last but not least, we have to move it up as a vertical shift of 2, so it means every point's going up 2 more points. Now, when we apply the vertical shift, we want to apply it to the second graph, not the first. So we're applying it to the blue graph, because the first graph doesn't have the other shifts in it. It doesn't have the first shift in it, and so if you apply it to the first graph, it will not look right. Okay? Ooh, that's an ugly graph. That's fine. So the purple graph, I'll mark that here as final. So the purple graph is our last one here. Alright, give that guy a shot. Take a second, pause the video, write it down. Here's the homework again. And that concludes phase and vertical shifts. Hope it makes sense.